Hello guys, how are you today? I'm Miss Susan Gabr. In this video, we'll study Unit 1 Force and Motion, Lesson 1 Motion in One Direction. Motion is part of our lives. We see people and cars moving on the ground, bird and aeroplane in the sky, fish and boats in the sea. All of these objects move in different directions in different speeds. When the object position or the object location change as the time passes. According to the position of another object, we can say that the object in a state of motion. The obvious question is this part, what is meant by motion? Motion is a change of an object location or the object position as the time passes according to the location of another object. And to simplify the concept of motion, we will study the motion in one direction, and this is the topic of our lesson for today. The path of objects that move may be in straight line or curved line, or the both of straight and curved together. For example, we have the motion of the train. The motion of the train is considered as example for the motion in one direction. Okay, when the train move, it may be move in forward or backward. So I don't know it move in straight line or curved line. So I can say that the motion of the train is considered example for the motion of in the straight line, okay, or curved line, or straight and curved together, but in one direction. But how we can describe and compare between motion of object? We can describe the motion of some object as speed is fast or slow by a physical quantity which is used to describe and measure the motion of object. So the speed used to measure the motion and describe it. Another definition, speed, it is the distance moved through a unit of time. Distance moved through a unit of time. So when we calculate the speed, we have to find the distance and the time. So the law of the speed depend on the distance at the time. So the two factors necessary for the description of motion, yes, very good, the distance that covered the motion and the time taken to cover this distance. So the speed with the V simple equal D, the first letter for distance, so it's represent the distance, divide the T, the time. But what about the measuring unit of the speed? As we say, the law of the speed V equal D divide T. So the D measured by meter, so the time measured by second. And when the D measured by kilometer, the time will measured by hour. So the measuring unit for the speed, yes, very good, meter per second or kilometer per hour. Okay, calculate the speed of runner who run 240 meters in 1 minute. So the problem in this part to convert the meter, the minute to the second. So to calculate the speed, we need meter per second or kilometer per hour. divide 60 seconds equals 4 meter per second. Okay, if we have in the race cars and one of these cars faster than the other, so this car taking a shorter time, so it fast, so it take a shorter time. If it's slow, so it take a longer time. Okay, give reason. The object speed increase as the time decrease, so the speed increase as the time decrease. So between the speed and the time, inversely proportional relation. How? According to the law. So we have to write the law of the speed, v equal d divide t. So the speed of the object is inversely proportional with the time. Another question. The object speed increase by increase. It's direct proportional. So the speed and the distance direct together at a constant time. So according to the speed law, v equals d divide t. So the speed of object directly proportional with the covered distance. What is meant by? A train covers a distance 240 kilometers in 2 hours. So we have the distance and we have the time, so we talk about the speed. So this means that the train moves with speed equals 120. So we divide the distance, we make the distance divide the time. So v equals d divide t, 240 divide the 2 hours. So it's 120 kilometers per hour. A car moves with the speed 150 kilometers per hour. So we have the speed. So we write the definition of the speed in this case. So when we have the distance and the time, we write the speed. When we have the speed, we make the definition of the speed. So this means that the car moves or cover a distance 150 in 1 hour. Okay, so we can describe the motion, as we say before, of some object around us as fast and other as slow by the speed as a physical quantity which is used to describe and measure the motion of the object, as the speed equals distance divide the time. Okay, the type of the speed. Types of the speed. We have 2 types of the speed. As we say, we have a race. When one of the cars move equal distance to the final or the end of the race, the equal distance in equal period of time, so it's regular or uniform speed. So uniform or regular speed, the object cover equal distance at equal period of time. So we have from the starting point, the start of movement, to the first distance, it cover, for example, 1 second, and from the first distance to the second distance, it cover 1 second, and from the second distance to the third distance, it cover also 1 second. So it's equal period, 20 in equal period of time, 1 second in 1 second in 1 second. So it's uniform or regular speed. What about when the object cover equal distance? Right, we said before 20 20 20 at unequal period of time. For example, the first distance covered in 1 second, the second distance in 1 second and a half, and the third distance in 2 seconds. So it moves in equal distance at unequal period of time. Or the object covered unequal distance. So from the starting point, he moved to the first distance in 20 meters, and from the first to the second distance, it represents 22. So it's irregular or unequal distance at equal period of time. 1 second, the first distance, 1 second, and in the second distance. So in this case, we can't make the law of the speed, V equals d divided t, but we calculate the addition of the total distance. For example, we have 20 in the first distance, the second distance 22, so we have 20 plus 22, divide the total time, 1 second plus 1 second, so it's a total, divide the total, it's average speed. So the average speed equals total distance divide total of total time. Okay, we have relative speed. What is the relative speed? If we have the cars move on the ground and we have someone or person that's standing on the side of the road, so this person is observer. He can see and calculate the speed of the car. So relative speed is the speed of moving object relative to the an observer. One more time, relative speed that relative to an observer. Okay. Give reason.